The Great Pyramid of Giza, an ancient structure that defies time itself. Built more than 4,500 years ago, standing nearly 147 meters tall, it was the tallest structure on Earth for almost 4 millennia. Made of over 2 million stone blocks, some weighing as much as 80 tons, aligned with breathtaking precision to the cardinal points. And yet, no cranes, no steel tools, no modern machinery. How? This question has puzzled scholars, engineers, and explorers for centuries. The records of its construction have been lost to time. What remains is the pyramid itself, a silent sentinel in the desert, daring us to uncover its secrets. Was it built using simple ramps and brute strength? Or could ancient Egyptians have possessed knowledge, techniques, that we have yet to rediscover? Today we explore the most fascinating theories surrounding the construction of the Great Pyramid. We will examine traditional models and daring alternatives. We will journey into the sands of time to witness one of the greatest achievements of human civilization. And perhaps, along the way, we will uncover something even greater: the boundless ingenuity of the human spirit. The Great Pyramid is a masterpiece of ancient engineering. Its sides are almost perfectly aligned with the 4 cardinal points, a feat still difficult today. Its stones, carved with such precision that not even a knife blade fits between them. Its original casing stones, gleaming white limestone, once reflected the sun so brightly that the pyramid was visible for miles across the desert. Inside, the mysteries deepen. Descending passages, hidden chambers, colossal granite blocks placed with pinpoint accuracy. Yet, no construction records remain. No blueprints, no written accounts detailing the exact methods used. How did the Egyptians transport these massive stones? How did they raise them to such heights? How did they align the entire structure so perfectly? Theories abound, some plausible, some fantastical. But the truth is, the Great Pyramid guards its secrets well, and so we continue to ask, how did they build it? And what does it reveal about the capabilities of the ancient world? To understand how the Great Pyramid was built, we must first understand its time. The Old Kingdom, the golden age of pyramid building. During the 4th dynasty, around 2570 BCE, Pharaoh Khufu, known to the Greeks as Cheops, commissioned the Great Pyramid. Egypt was a prosperous, unified state. Its wealth flowed from agriculture along the Nile. With a stable central government, pharaohs could mobilize vast resources and manpower. Tens of thousands of workers, not slaves but skilled laborers and farmers during the flood season, were brought to Giza. They lived in nearby workers' villages. They ate well: bread, beer, meat. They labored under the desert sun, moving, cutting, and setting stone. Religious devotion also played a role. The pyramid was a monument to divine kingship, a bridge to eternity. And so, during this remarkable period, humanity embarked on one of its greatest engineering projects, a legacy that would outlast empires. The Great Pyramid did not appear out of nowhere. It was the culmination of centuries of architectural evolution. Early Egyptian tombs were simple, rectangular mastabas built of mud brick. Then came the visionary architect Imhotep, who designed the first stone pyramid for Pharaoh Djoser, the step pyramid at Saqqara. This innovation marked a turning point. Architects experimented with shapes, from stepped structures to smooth-sided pyramids. Mistakes were made. The bent pyramid of Pharaoh Sneferu shows a dramatic change in angle midway, a learning experience in engineering. Eventually, these lessons led to the construction of the true pyramid form. By the time Khufu reigned, the techniques, experience, and ambition were in place, ready to create the greatest pyramid of all. Building the Great Pyramid required an extraordinary feat of organization. Estimates suggest that around 20,000 to 30,000 workers labored at Giza during peak construction. This workforce was divided into teams, each with specialized roles. Stone cutters quarried limestone and granite. Haulers transported blocks by sled and boat. Masons shaped and placed stones. Overseers coordinated logistics. Support staff cooked, brewed beer, wove ropes, and maintained tools. Massive supplies were needed daily: food, water, copper tools, wood, and clothing. Efficient planning kept the project moving. Hieroglyphic inscriptions tell us about team names. Groups competed for pride and excellence. This was more than labor. It was a national project imbued with religious and cultural meaning. Each worker knew they were helping to build a bridge to eternity. One of the most enduring theories about how the Great Pyramid was built is also the simplest, the straight ramp theory. The idea is straightforward, but monumental in scale. A massive straight earthen ramp would have been constructed, extending outward from one face of the pyramid. This ramp allowed workers to haul stone blocks up to each new layer as the pyramid rose. Simple in concept, but staggering in execution. To build such a ramp, the Egyptians would have needed to move and shape millions of tons of earth and stone. Some estimates suggest the ramp itself might have been as large or larger than the pyramid it served. Imagine it, a colossal earthwork, gradually sloping up toward the heavens. Hundreds of teams hauling sledges laden with stone blocks. Ropes straining, sweat pouring under the Egyptian sun. Chants rising to coordinate the pull of thousands of hands. Workers constantly adding to the ramp as construction progressed. And when the pyramid was complete, the entire ramp would have been dismantled, its materials returned to the desert. No trace would remain. Supporters of the straight ramp theory point to its simplicity. It requires no lost technology, no mysterious mechanisms, just human determination and organization. But the theory is not without its challenges. As the pyramid rose higher, the ramp would need to grow ever longer, or steeper. An excessively steep ramp would make hauling massive stones nearly impossible. An excessively long ramp, stretching over a kilometer, would demand immense resources and labor. And so, while the straight ramp theory remains one of the most accepted models, it raises questions as vast as the structure itself. Could the ancient Egyptians truly have built such a colossal earthwork, and then erased nearly every trace of its existence? Or was there another way? The straight ramp theory is compelling in its simplicity. It relies on basic principles: gravity, friction, human strength. Advantages? There are many. First, it aligns with what we know about ancient Egyptian engineering. The Egyptians were master builders of earthworks. They constructed colossal causeways, canals, and ceremonial ramps. They possessed the manpower and organizational skill to undertake such a feat. Second, the materials required were abundant: earth, rubble, stone, all readily available near Giza. No exotic technology required. Third, the method is scalable. As the pyramid rose, the ramp could simply be extended and heightened. Simple tools, sledges, ropes, levers, would suffice to move even the heaviest blocks. But the straight ramp theory also faces serious challenges. First, the sheer size of the required ramp. To maintain a practical incline, say 7 to 10%, the ramp would need to stretch far into the desert. Some calculations suggest a ramp over 1.5 kilometers long would be necessary to reach the pyramid's final height. Such a structure would dwarf the pyramid itself. Second, the logistics of construction. Building and maintaining such a massive ramp while simultaneously constructing the pyramid would be an enormous undertaking. It would double the required labor and materials. Third, the lack of physical evidence. To date, no traces of such a vast straight ramp have been found at Giza. While erosion and dismantling could account for this, it remains a point of debate. Finally, the problem of space. A straight ramp would cover the front face of the pyramid, obstructing the placement of casing stones on that side until very late in the process. This complicates the finishing and alignment of the structure. And so, while the straight ramp theory remains a logical and widely taught model, many scholars believe it cannot fully explain the construction of the Great Pyramid on its own. Perhaps the Egyptians used a straight ramp for part of the process. But as we will see, other theories offer intriguing alternatives. As scholars debated the limitations of the straight ramp theory, a new idea emerged, one both elegant and practical: the spiral ramp theory. The concept is simple. Instead of a massive straight ramp extending outward, workers built a spiral ramp that wrapped around the pyramid itself. This spiral would rise gradually as construction progressed, allowing teams to haul stones directly to each new layer without requiring an enormous external structure. Advantages? They are significant. First, a spiral ramp would require far less material. Its footprint would remain close to the pyramid, conserving space and resources. Second, it would eliminate the need for a kilometer-long ramp. As the pyramid rose, the spiral would simply coil higher, providing continuous access. Third, it would solve a key finishing problem. A spiral allowed workers to place casing stones as they ascended, No large straight ramp blocking the faces. But how might such a ramp have been constructed? Some propose an external spiral, built of mud brick and stone, hugging the pyramid's sides. Others suggest an internal spiral, ramps embedded within the pyramid structure, using temporary openings to maneuver blocks. Evidence remains elusive. No clear remains of an external spiral have been found. Yet hints of internal features, unusual voids and passages, spark intriguing possibilities. Critics point out that maneuvering large stones around tight spiral turns would be challenging. But supporters argue that with careful engineering and coordination, the spiral ramp could have provided a remarkably efficient solution. And visually, it fits. Ancient Egyptian art often depicts ramps coiling upward in temple construction scenes. Could the builders of the Great Pyramid have used a similar technique, refined and perfected on a colossal scale? Perhaps. The spiral ramp theory remains one of the most attractive alternatives to the massive straight ramp. A solution as clever as it is elegant, befitting the ingenuity of ancient Egypt. Among the most intriguing modern theories is one that takes us not around the pyramid, but inside it. The internal ramp theory. First proposed by French architect Jean-Pierre Houdin, this idea suggests that the Great Pyramid contains a hidden spiral ramp, built within its structure. According to this model, the Egyptians constructed an internal corridor spiraling upward just beneath the pyramid's outer surface. As the pyramid rose, workers used this internal ramp to haul stones to each successive level. The concept is both elegant and efficient. An internal ramp would solve many of the logistical problems faced by external ramps. No colossal straight ramp to build or dismantle, no spiral blocking the placement of outer casing stones. Instead, a self-contained pathway, perfectly integrated into the pyramid's design. But is there evidence? This is where the theory becomes fascinating. Modern surveys using advanced technologies, such as microgravimetry and muon detection, have revealed mysterious voids and anomalies within the Great Pyramid. Some of these features correspond with the predicted path of Houdin's internal spiral. Furthermore, the pyramid contains curious notches, small openings visible on its exterior. Houdin proposed that these notches served as turning points, allowing blocks to be rotated and maneuvered along the internal ramp. Skeptics argue that the evidence is inconclusive. No direct access to the supposed ramp has been confirmed. The voids may have alternative explanations. But supporters maintain that the internal ramp offers a compelling solution, one consistent with both engineering logic and the pyramid's architecture. If true, it would mean the Great Pyramid is not just a marvel of external precision, but a masterpiece of hidden engineering as well. A spiral road to the stars, concealed within a mountain of stone, waiting to be discovered. If the internal ramp theory is correct, what evidence supports it? Here, modern archaeology offers tantalizing clues. Over the past 2 decades, researchers have used advanced techniques to scan the Great Pyramid's interior. Muon tomography, a method that detects cosmic particles passing through stone, has revealed anomalies. Large voids and empty spaces within the pyramid's structure. Some of these voids trace a pattern consistent with Houdin's proposed internal spiral. Moreover, visible features on the pyramid's exterior hint at this hidden design. At several levels, the pyramid shows small notches or indentations. Houdin argues these were turning points, locations where massive blocks were rotated and redirected along the internal ramp. Ancient construction scenes depicted in Egyptian art often show blocks being turned and maneuvered using wooden sleds and levers. Such techniques would fit perfectly within the confined space of an internal corridor. Beyond the scans and notches, other architectural clues emerge. Detailed analysis of the pyramid's stone layers reveals subtle patterns in the courses of blocks, as if certain layers were designed to accommodate an internal path. Some blocks show irregularities in placement, perhaps evidence of ramps or platforms integrated into the structure during construction. But perhaps the strongest evidence lies in what we do not find. No remains of a colossal external ramp have been uncovered, no clear traces of the immense earthworks required by the straight ramp theory. This absence suggests that much of the construction may have been internalized, leaving few external traces for modern archaeologists. Of course, skepticism remains. Void detection is still an evolving science. Anomalies may have multiple explanations, and the notches, while intriguing, could serve other purposes. But the pattern is compelling. Layer upon layer of indirect evidence points to the possibility of a hidden engineering marvel within the pyramid itself, a secret spiral winding upward through the heart of stone. If future discoveries confirm this, it will rewrite our understanding of how the ancients built one of the world's greatest wonders. Beyond ramps, whether straight or spiral, some scholars and engineers propose that the ancient Egyptians may have used another powerful tool. The lever. Simple, yet incredibly effective. The lever and pulley theory suggests that wooden levers combined with primitive pulley-like systems were key to lifting and positioning the massive stone blocks of the Great Pyramid. How might this have worked? Imagine teams of workers using long wooden beams, pivoted on stone or wooden fulcrums, to gradually raise a stone block by small increments. With each lift, workers would insert wooden cribbing or packing material beneath the stone. Bit by bit, step by step, the block would rise to its desired level. In parallel, wooden sleds and ropes could be used to maneuver blocks into precise positions. Pulleys, as we know them today, were not documented in ancient Egypt, but simple rope and roller systems likely existed. Archaeological finds suggest that the Egyptians were masters of rope-making and woodcraft. Scenes from tombs and temple walls depict elaborate rope harnesses and wooden sleds capable of supporting immense weight. Combined with levers, these tools would have allowed remarkable control over the movement of massive stones. Supporters of the lever theory argue that it solves key problems. It requires far less space than large external ramps. It allows for precise placement of blocks, critical for the pyramid's incredible alignment and fitting. And it matches the technological level of the Old Kingdom. No advanced machinery, just the intelligent application of basic physics. Critics, however, point out that lifting blocks this way would be extremely labor-intensive, and it is unlikely to have been the sole method used for every stone. More probably, levers and rope systems were used in combination with ramps, particularly for the final placement of casing stones and for maneuvering stones into tight internal chambers. Still, the lever remains a timeless tool. Its elegant simplicity speaks to the genius of the builders of Giza, and it reminds us that even with the humblest of tools, great wonders can be achieved through ingenuity, cooperation, and determination. Could levers alone have built the Great Pyramid? Most experts believe the answer is no, but combined with ramps and sledges, levers may have played a critical role. Let us consider the challenges. Moving a 2.5-ton limestone block across level ground is difficult enough. Lifting it vertically is even harder. A straight or spiral ramp provided the main means of elevation, allowing stones to be hauled gradually upward. But ramps alone do not account for everything. Positioning casing stones with millimeter precision required finesse. Hauling massive granite beams into the king's chamber demanded more than brute force. Here, levers and primitive pulleys would have shone. In confined spaces where ramps were impractical, teams of skilled workers using levers could control the final placement of stones. Historical depictions support this view. Egyptian art often shows workers employing ropes, sleds, and levers in construction scenes. Temples and tombs reveal no advanced lifting devices, but clear evidence of ingenious manual techniques. Experimental archaeology also offers insights. Modern teams have successfully raised multi-ton blocks using only wooden levers and rope systems, replicating ancient methods. Such experiments demonstrate that with coordinated effort and patient technique, enormous stones can be maneuvered with remarkable accuracy. Combining ramps for mass elevation, sledges for horizontal transport, and levers for precise placement offers a holistic model for pyramid construction. This multi-method approach aligns with the Egyptians' pragmatic genius. They did not rely on a single technique, but applied the right tool for each task. Levers and simple rope systems provided the fine control that brute force ramp hauling could not. In this light, the lever theory does not replace ramp theories, but enhances them. Together, these techniques form a plausible, elegant answer to one of history's greatest engineering puzzles, a fusion of simplicity, ingenuity, and human will that still inspires awe today. Among the most mysterious and controversial theories of pyramid construction is the idea that sound itself played a role. Acoustic levitation. This hypothesis suggests that the ancient Egyptians may have harnessed sonic energy to lift and move massive stones. At first glance, it sounds like science fiction, yet the concept of using sound waves to move objects is scientifically plausible, at least in principle. Modern experiments have shown that highly focused sound waves can suspend small objects in midair, a phenomenon known as acoustic levitation. Could such a principle have been scaled up in ancient times? Proponents of this theory point to several curious clues. First, the extraordinary precision of the Great Pyramid stone placement. Blocks weighing tons are aligned with sub-millimeter accuracy. How were such stones maneuvered so delicately? Second, the properties of the pyramid's internal chambers. The king's chamber, in particular, exhibits unusual acoustic qualities. Some researchers report powerful resonances when specific frequencies are generated within the space. Could these resonances reflect a lost understanding of sound manipulation? Third, ancient myths and legends. Various Egyptian texts and oral traditions speak of tones of power, sacred sounds associated with construction and creation. Some fringe theorists suggest that chants, drums, and resonant instruments were used not just ceremonially, but functionally. But the evidence is largely circumstantial. Skeptics argue that no hard proof exists that the Egyptians possessed the technology required for large-scale acoustic levitation. The forces needed to lift multi-ton blocks with sound alone would require energy levels difficult to achieve, even today. Furthermore, no archaeological artifacts definitively linked to such technology have been found. Yet, the theory endures, perhaps not as a literal explanation, but as a reminder of the power of sound in ancient Egyptian culture. Music, chant, and rhythm played vital roles in ritual, labor, and architecture. It is conceivable that sound, at the very least, was used to coordinate and enhance the physical efforts of the builders. And who knows? Future discoveries may yet reveal unexpected insights into the acoustic mysteries of the Great Pyramid. For now, acoustic levitation remains one of the most intriguing and elusive possibilities in our quest to understand this ancient wonder. If there is one theory that captures the imagination of both scholars and the public alike, it is the idea that the ancient Egyptians may have possessed lost technologies, knowledge, and techniques that have not survived the march of time. This is not to suggest flying machines or lasers, but rather advanced methods of engineering, materials science, or construction techniques that remain unknown to us. Consider this: the Great Pyramid's blocks, millions of them, fit with such precision that even modern engineers are humbled. Its alignment with true north remains unparalleled, achieved without modern surveying equipment. Its internal chambers and corridors display a level of architectural mastery that suggests deep understanding of geometry, acoustics, and materials. Could it be that the Egyptians employed tools, compounds, or methods that left little trace in the archaeological record? Some researchers point to the extraordinary durability of ancient Egyptian concrete-like materials. Others suggest that techniques for softening stone through plant-based chemical processes may have allowed certain blocks to be shaped more easily than previously thought. Intriguingly, oral traditions among some modern Egyptian stoneworkers mention the use of mysterious pastes or solutions in shaping and smoothing stone. Yet no definitive chemical formula or physical artifact has been conclusively identified. Another area of speculation involves energy and vibration. Might the Egyptians have understood how to harness certain vibrational frequencies to assist in moving or positioning stone? While hard evidence remains elusive, the enduring acoustic properties of the king's chamber and other sacred spaces suggest that sound and vibration held significant cultural and perhaps functional meaning. Proponents of the lost technology theory argue that the lack of surviving construction records may itself be telling. Such knowledge may have been closely guarded, passed orally within select priestly or engineering castes. With the eventual decline of the Old Kingdom, this knowledge could have vanished with the collapse of centralized authority. Critics caution that extraordinary claims require extraordinary evidence. Indeed, we must be careful not to project modern fantasies onto the ancient past. But it is equally important to remain open to the possibility that the ancient world was far more sophisticated than we often assume. The lost technology theory reminds us that the past still holds many secrets, waiting beneath the sands for those with the curiosity and courage to seek them. As we seek to understand how the Great Pyramid was built, archaeology continues to uncover new and often puzzling clues. Many of these discoveries raise more questions than answers. Consider the mysterious voids detected within the pyramid. In 2017, the Scan Pyramids project used advanced muon tomography to reveal a previously unknown large void above the Grand Gallery. Its purpose remains unknown. Is it a structural feature? A space to relieve weight? Or could it conceal something more? No direct access to this void has been achieved. Its presence only deepens the pyramid's enduring enigma. Another mystery involves certain tool marks found on pyramid stones. While most blocks show typical copper chisel marks, some exhibit irregular patterns suggesting techniques not fully understood. Could different teams have used varied methods? Or might experimental or lost techniques account for these anomalies? Then there are the so-called core samples, small circular drill holes in some blocks with spiral striations difficult to replicate using known Old Kingdom tools. Do these marks indicate the use of tubular drills, possibly with abrasives, whose exact nature remains uncertain? Elsewhere on the Giza Plateau, quarries and causeways reveal additional puzzles. Transport paths show wear patterns suggesting both sledges and other, less understood methods of movement. Massive stones weighing up to 70 tons were somehow maneuvered with extraordinary control and precision. Even the layout of the pyramid's internal chambers poses questions. Why such exact alignment with celestial features? How were massive granite beams lifted and set in confined spaces? Some scholars propose that a combination of known and unknown techniques was used, each optimized for specific challenges. Yet, many aspects of the construction process remain elusive. And then there are the unfinished projects, pyramids and quarries where work abruptly ceased. These sites offer a rare glimpse into ancient construction methods, but also reveal gaps in our understanding. Were certain techniques deliberately hidden, known only to elite builders? Or have centuries of erosion and human activity simply erased the evidence? One truth is clear. The more we learn about the Great Pyramid, the more its mysteries deepen. Each discovery opens new avenues of inquiry, reminding us that even the most iconic of ancient structures still holds secrets waiting to be revealed. After centuries of study, why is there still no single, universally accepted theory for how the Great Pyramid was built? The answer lies in the pyramid's extraordinary complexity and in the limits of both ancient and modern knowledge. First, the pyramid itself reveals few clear clues. Its original construction records, if they ever existed, have vanished. No blueprints, no surviving architectural texts detail the methods used. What remains is a silent structure of stone, its secrets locked within its very fabric. Second, erosion and time have erased much evidence. Ramps, scaffolding, and construction tools, mostly built of perishable materials, would not survive millennia. Even stone ramps or causeways could have been dismantled or repurposed. Third, the Egyptians likely used a combination of methods. A straight or spiral ramp alone cannot explain every aspect of construction. Levers, rope systems, specialized sledges, and possibly now lost techniques may all have played roles at different stages. This multi-method approach complicates any search for a single, unified theory. Fourth, experimental archaeology provides insights but also limitations. Modern reconstructions can simulate ancient techniques, but can only approximate the true scale and context of pyramid construction. Many practical challenges remain unsolved, such as the precise method for positioning massive granite beams in confined spaces. Finally, academic caution plays a role. Scholars are wary of endorsing speculative or fringe theories without strong evidence. At the same time, traditional models leave gaps that cannot be ignored. The result is a field marked by healthy debate and ongoing mystery. As new technologies emerge, from advanced scanning to AI-assisted modeling, future discoveries may clarify the picture. But perhaps we must accept that some aspects of the pyramid's construction may forever remain unknown. And in that uncertainty lies part of the pyramid's enduring power. It is not merely a monument of stone, but a monument to human ingenuity, perseverance, and mystery. Its unanswered questions invite us to imagine, to explore, and to marvel at what ancient hands achieved beneath the Egyptian sun. As our exploration deepens, one possibility becomes increasingly clear. The Great Pyramid was likely not built using a single method, but through a sophisticated combination of techniques. Imagine the scene. At the base, broad, stable ramps allowed workers to haul stones en masse. As the pyramid rose, spiral ramps may have provided access to higher layers, hugging the growing monument. Within the pyramid's core, internal ramps or corridors could have facilitated the transport of key blocks. At critical junctures, particularly in the king's chamber, levers and rope systems likely enabled precise placement of massive granite beams. Throughout the process, workers adapted their methods to changing needs. Sledges, rollers, lubrication, these were employed on the ground and on ramps. Livers, wooden cribbing, and simple but powerful lifting techniques handled the fine adjustments. Coordination was key. The pyramid's construction likely involved thousands of skilled workers, operating under the direction of master architects and overseers. Each method was chosen for its practicality in a given context, a dynamic, evolving process rather than a rigid plan. This combined approach also explains why no single theory fully accounts for all the evidence. Different methods leave different traces, or none at all. Erosion, dismantling, and the passage of millennia have obscured much of the physical record. Yet through a synthesis of known techniques, and perhaps some still to be rediscovered, the Egyptians achieved one of history's greatest engineering feats. A feat that reminds us, ingenuity lies not in any single tool, but in the mastery of all tools at one's disposal, and in the power of human cooperation, driven by vision and purpose. What can the mysteries of the Great Pyramid teach us today? In an age of supercomputers, AI, and space travel, what relevance do ancient stones in the desert still hold? More than we might think. First, they remind us of the power of collaborative effort. The Great Pyramid was not the work of a single genius, but of thousands of individuals, united by a shared vision. Architects, engineers, craftsmen, farmers, laborers, each played a vital role. Their combined knowledge and perseverance achieved what no one alone could have done. Second, the pyramid teaches us humility. Despite our technological advances, we still do not fully understand how this ancient structure was built. Each new discovery challenges our assumptions, reminding us that progress is not always linear, and that much ancient knowledge may have been lost or forgotten. Third, the pyramid inspires scientific curiosity. It shows that great mysteries can endure for millennia, beckoning each new generation to question, explore, and imagine. In this way, the Great Pyramid serves as a timeless laboratory, a place where archaeologists, engineers, physicists, and historians converge. Advanced scanning technologies, from muon detectors to ground-penetrating radar, are now being used to probe its secrets. AI is helping to model construction scenarios, testing theories in virtual space. Yet, the answers remain elusive, reminding us that technology alone is not enough. We must also cultivate wonder, patience, and respect for the past. Finally, the Great Pyramid challenges us to think about legacy. Its builders knew they would not live to see their work completed, yet they labored with devotion, creating a monument meant to endure beyond their lifetimes. In our own era of rapid change and disposable culture, the pyramid stands as a testament to enduring purpose, a message across time that what we build, in stone, in knowledge, in spirit, can echo through the ages, if we dare to dream as boldly as those who once shaped the sands of Giza. And so, we arrive at the edge of mystery. After all the theories, models, and modern experiments, many questions about the Great Pyramid remain unanswered. How exactly were the internal chambers constructed with such precision? What methods allowed massive granite beams to be set within confined spaces? Did spiral or internal ramps exist, or have they eluded discovery? Were acoustic properties designed intentionally, or are they a remarkable coincidence? Did the ancient Egyptians possess techniques, materials, or knowledge that we have yet to rediscover? These questions are not signs of failure, but of the pyramid's enduring power to inspire curiosity. In a world that often values certainty above all, the Great Pyramid reminds us that some mysteries endure, and that this is not a weakness, but a gift. For it is the unknown that drives us to explore, to innovate, and to imagine beyond the boundaries of current knowledge. The Great Pyramid invites us, across 4,500 years, to enter into a dialogue with the past. It asks us to consider not only how it was built, but why we continue to care so deeply about this question. Perhaps the answer lies in something deeper than stone and geometry, in the human desire to create something greater than ourselves, something that will stand the test of time. As you contemplate the Great Pyramid, ask yourself, what mysteries might we leave for future generations to ponder? What legacies of stone or thought will we leave behind? And in the spirit of the ancient builders, will we dare to dream and build with the same boldness, patience, and wonder? The answers, like the pyramid itself, await those willing to seek them beneath the sands of time. As we conclude this journey through stone and time, let us reflect upon the spirit that animated the builders of the Great Pyramid. For beneath the layers of limestone and granite, beneath the mathematical precision and architectural genius, lies something deeper: the spirit of exploration. The ancient Egyptians did not simply build a tomb, they built a gateway to eternity. Their work embodies a profound drive to understand the cosmos, to harmonize human creation with the stars, and to leave a legacy that would echo across millennia. They were not afraid to dream on a colossal scale, to envision a monument that would stand long after their names were forgotten, speaking to future generations through the universal language of form and mystery. In this, they remind us of the timeless human desire to reach beyond the known, to push the limits of what is possible. Each stone placed upon another was an act of faith, faith in their craft, faith in their gods, faith in the future. Today, as we gaze upon the Great Pyramid, we are witnessing the triumph of that spirit, a monument that has withstood earthquakes, invasions, and the erosion of time. A testament not only to the builders' skill, but to their vision. And so the Great Pyramid continues to inspire, to call to explorers, scientists, philosophers, and to each of us. It asks, what will you build? What mysteries will you dare to pursue? What legacy will you leave behind? In honoring the ancient spirit of exploration, we are reminded that the greatest pyramids yet to be built may not be made of stone, but of ideas, dreams, and the enduring quest for knowledge. The sands of time still shift around the Great Pyramid, and as long as they do, its timeless message will remain. Dare to wonder, dare to build, dare to seek the eternal.